Hello. In this video, we're going to start chapter 1, which is all about chemistry, matter, and measurement. So chemistry is really central to the sciences. We need to understand chemistry in order to better understand other subjects like biochemistry, biology, geology, physics, even into astronomy, geochemistry, and medicine. So what we'll do is we'll define chemistry and we'll go into a little bit of detail about what chemistry is. So what is chemistry? Well, chemistry is the study of matter. And matter is anything that has mass and takes up space. So anything around you really is matter, such as your desk, a notebook, a pencil, even the air. It's all matter. So really in chemistry, we're trying to better understand the world around us. Now, mass is a measurement of the amount of matter in an object. So maybe we would weigh something to determine how much mass something has. And we might use units of grams or pounds, for example. But mass is actually a little bit different from weight. Just as an example, an object has the same mass on Earth and on the Moon. However, that same object weighs more on Earth. So why is that? Well, weight is actually a measurement of the gravitational force that's acting on an object. So Earth has a much higher gravitational force than the Moon. So an object will always weigh more on Earth than it does on the Moon. However, mass will stay the same between the two. Because mass, we're really just looking at the object itself. We're not really measuring the effect of a gravitational force on that object when we're considering mass. So for example, let's say we have an object that has a mass of 50 kilograms. That would be the same on the Moon. Now let's say we weigh an object on Earth as 110 pounds. It would actually have a different weight on the Moon of 42 pounds. There's actually a really cool website you can go to. The link will be in the PowerPoint slides. And you can type in the weight of an object and see what that object would weigh on other planets. So for example, Jupiter is much, much bigger than Earth. So it has a much, much larger gravitational pull than Earth does. So objects weigh like many times more on Jupiter than they do on Earth, for example. Now, scientists do need a way to classify matter so that they can accurately describe it to others. So scientists will classify the properties of matter into two general categories: physical properties and chemical properties. Now, physical properties are those that can be observed without changing the composition of the object. So this would be something like the size of the object, its shape, its color, its mass, and that's something that's not going to change about the object. But chemical properties are characteristics that describe how that matter changes its chemical structure or composition. So I kind of like to think about this as if I'm looking at myself in the mirror, my physical properties are I have brown hair, blue eyes, and those are things that cannot change unless I use some sort of chemical reaction, right? So physical properties again are characteristics that cannot change about an object. Now, let's say I dye my hair. Let's say I dye it red or blonde. That would be a chemical property that my hair can change color if it reacts with a dye. But other examples of chemical properties are flammability, so the ability of something to catch on fire, and then the ability of something to react with something else. So let's look at an example of a copper penny. Before 1983, pennies were about 95% copper. But that got to be a little too expensive, so now pennies are made with zinc and they're coated with copper to maintain that same look that the penny has always had. So pennies now are only about 2.5% copper. Now, some physical properties of copper, we have something called density, and we'll talk more about what density is in later slides, but it's basically a ratio of something's mass to volume. So copper has a very specific density of 8.96 grams per milliliter, and that's never going to change. Copper will always have that same density. Copper also melts at a very specific temperature, and that will never change. It will always melt at that temperature. So that's its physical property. Now, here we're listing a melting point in a temperature unit called Kelvin, and it's given a capital K abbreviation. But we'll learn more about Kelvin later, so don't worry about it right now. But copper also has a very specific boiling point, so it boils at that temperature, and that never changes for copper. Additionally, some appearance descriptions here. Copper is usually reddish-brown, right? It's also malleable and ductile, which means that copper can be shaped into sheets or wires, and copper is actually used in a lot of cookware for that reason because it can easily be shaped. So again, these are all physical properties, right? But what about chemical properties of copper? So let's talk about the Statue of Liberty, which actually was once pure copper. So the Statue of Liberty used to be a reddish-brown color, but it has since reacted with air and moisture over time to form a new compound called copper oxide. And copper oxide has a bluish-green color. So now the Statue of Liberty is bluish-green. You might actually notice the same color on really old awnings or rooftops in older cities. They used to be copper, but just over time they've reacted with moisture and air to turn this bluish-green color. But what we've learned from that is copper can react with just air, and it will turn more of a brownish color rather than a reddish brown. But if you add moisture into that reaction, copper will turn blue-green. And that's because copper is turning into something completely different. It's changing its chemical structure. It's turning into copper oxide. All right, so let's practice describing some physical properties and chemical properties of matter that we're very familiar with, which is water. So I would ask you here to pause the video and try to come up with some physical properties of water and then some chemical properties of water. And then when you unpause the video, we'll go over some examples together. All right, so let's think up some physical properties of water. So typically, water is clear, right? It should be colorless, hopefully. What else? Let's see. Water boils at a very specific temperature. It boils at 212 degrees Fahrenheit, or we could write that in degrees Celsius. That would be 100 degrees Celsius. We also know water freezes at a very specific temperature. So water freezes at 32 degrees Fahrenheit, or we could also write that as 0 degrees Celsius. Now, what about some chemical properties? So we talked about flammability being a chemical property, and actually the fact that water is not flammable can be a chemical property. So it's, oh, I spelled flammable wrong. Let's see, not flammable. Flammable, there we go. So water can put out fires, right? And then just earlier we saw that water can react with air and copper to form copper oxide. And of course, water can do many other reactions as well. So these are just a few examples. You might have listed more, and that's great. So don't feel like your answers are wrong if they're not up here on the slide. I probably just didn't cover all of the possible properties of water. But hopefully this is a good example of the difference between physical properties and chemical properties. Now, there's one more way that we can classify matter. Actually, there's a few more ways, but in this video, we're just going to wrap up by talking about physical versus chemical changes of matter. So physical changes occur without a change in composition of matter. So for example, water can freeze, it can melt, it can evaporate and turn into a gas, but water itself is staying the same, right? So H2O remains as H2O, even if it's freezing, melting, or turning into a gas. The only thing that's changing is its physical state. But in chemical changes, we actually see a change in composition of matter. So for example, if we burn paper, it doesn't stay paper, right? It turns into ash and smoke. Also, we said earlier that if copper reacts with air and water, it forms a completely new compound called copper oxide. So again, physical changes, the chemical staying the same chemical, it's just changing its physical state. But with chemical changes, we have a reaction. So something is becoming a different compound. So let's practice. Let's classify the following as a physical change or a chemical change. So we have ice cream melting, wood burning, steam rising from a cup of tea, and iron rusting to form iron oxide. So I encourage you to pause the video and work through these on your own. And then when you're done, you can unpause and we'll go over them together. All right, so let's see. Is ice cream melting a physical change or a chemical change? Well, the ice cream itself isn't turning into something new, it's just changing its physical form into more of a liquid, right? So this would be a physical change. What about wood burning? Well, as the wood burns, it turns into ash and smoke. So that would be a chemical change because the wood itself is changing its chemical composition. The next one is steam rising from a cup of tea. So the tea is made up of water and tea leaves, right? And it sounds like the water is so hot that it's turning into a gas or steam. So the water itself isn't turning into something different. It's just becoming a different physical form, a gas instead of a liquid. So this would be a physical change. And then what about iron rusting to form iron oxide? Well, we can see that iron is becoming something completely different, iron oxide. So this would be a chemical change. All right, so I think we'll end this first video here. And in the next video, we're going to talk about more ways that we can describe or classify matter. So I will see you then.